Bright Career Institute. We are going to study the chapter isomerism, and it's a very important chapter for the board in completing exam purpose. Okay. So isomerism. What is isomerism? Two or more compounds having the same molecular formula but different physical and chemical properties are called isomers, and this phenomenon is called isomerism. Say example C6H12. These have the different structures and they have different physical and chemical properties. So these all are isomers of C6H12. Isomers are broadly divided into two parts. One is structural, also known as constitutional, and other is stereo. In structural or constitutional isomers are divided into six parts. One is chain isomers, second is position isomers, third is ring chain, fourth is functional isomers, next is metamerism, and last one is tautomerism. And stereoisomers are divided into conformational and configurational. Chain isomers. Compounds having the same molecular formula but different arrangement of carbon chains or skeleton within the molecule are called chain isomers, and the phenomenon is termed as chain isomerism. Here you can see that the different arrangement of the carbon chain. These are all three examples are given of the molecular formula C6, H14 and O. These all are examples of chain isomers. Position isomerism. The compounds having the same molecular formula but differ in the position of the functional group and carbon-carbon multiple bond or substituent group are called position isomers, and the phenomenon is termed as position isomerism. These are two examples of the position isomerism. You can see that here the position of the OH group is number 1, and here the position of the OH is number 2. So these are called the position isomer. Sometimes it's very difficult to distinguish between position isomerism as well as chain isomerism. So we made one tricks. The tricks is called PG number, where the P stands for the parent carbon chain and G the group having the carbon. Okay. Now we can say that if the PG number is different, we can call it the chain isomer. We can calculate the PG number by using the parent chain, counting the parent carbon chain and group having the carbon. Suppose this is all the three examples, whether it is chain isomers or position isomer. So number 1, it should be counted from this side, because the OH group is attached to this carbon directly. So number 1, 2, 3, 4, 5 and 6. So the parent carbon chain is 6, and there is no carbon substituent present in this molecule. So the PG number should be 6 and 0. And you can see that in the next example, the OH group is directly attached to this carbon, so it should be counted from this side. So number 1, 2, 3, 4, 5. So PG number should be the 5, and one carbon substituent is present, so the PG number should be the 5, 1. And in the last example, you can see the OH group is directly attached to this carbon, so it's a number counting it as number 1, 2, 3 and 4. There is a parent carbon chain, so P is 4 and 2 carbon substituent group is present, so its PG number is 4, 2. You can see that all PG number are different, so it is called the chain isomer. In other example, like the ring compound, you can see that the page number, how we can count, because here OS is directly attached to this carbon, so we can counting from this carbon number 1, 2, 3, 4, 5, 6. So page number is 6, and here no carbon substituent is present. The other substituent is present, that is the OS, but OS we are not counting here, because we already written that G group having the carbon only. So their page number should be 6, 0. In the other examples, you can see the counting from this group 1, 2, 3, 4 and 5. So page number 1 comes carbon substituent is present, so page number should be the 5 and 1. So these are two, the page numbers are different, so it's considered as same isomers. In the other examples, if the page numbers are same, then what is called? If the page number is same, it's called the position isomers. You can calculate that the page number 1, 2, 3, 4. You can see that the page number both had the same page number, so it's called position isomers. And the next one is also you can calculate the page number and both having the same page number, so it is called the position isomers. So we can try out some other examples. So how to find out the page number? You can see the number 1 questions. What is the page number? 1, 2, 3, 4, 5. 5 is and 1 carbon substituent present, the 5, 1. And in other, you can see that other is 1, 2, 3, 4, 5, 5, 1. Both have the same page number, but you can see that the number 2 positions have the carbon substituent. In here also the number 2 having the same carbon substituent, so it is an identical structure. In the next example, we can see that number 1, page number 1, 2, 3, 4, 5, 6. 6 carbon are having 1 carbon substituent, but both have different molecular formula. You can see that the different molecular formula, so it is not an isomer. And number 3, you can check out the page number 1, 2, 3, 4. 4, 1. And here 5, 0. So both have different page numbers, so it is considered as a same isomers. You can calculate the other two also. That in the next example is 6, 0 and 6, 0. So the same page number, so it's considered as a position isomers. But the next examples, you can see that 1, 2, 3, 4, 5. Here also the 1, 2, 3. The 3 having the same identical structure, so it's not the isomers. मैं इसको skip कर देता हूँ. Functional group isomerism. The compound having the same molecular formula but different functional groups in the molecule are called functional isomers. And this phenomenon is termed as functional group isomerism. Okay, we have selected 6 types of functional isomers which are very important for board as well as JEE purpose. First one is carboxylic acid versus esters. Second one is alcohol versus ethers. Next one is thiol versus thioethers. Number 4, aldehyde versus ketones. Number 5, cyanide versus isocyanate. Number 6, alcohol versus phenol. Number 7, amines. Carboxylic acid versus esters. So this is example of esters, and this is the example of carboxylic acid, and both has same molecular formula, so it's belong to functional group isomers. You can see here also the methyl cyclopentane pentane carboxylate. This is the example of esters, and this is the cyclohexane carboxylic acid is an example of acid, carboxylic acid. So both have the same molecular formula, so it is considered as functional group isomers. In alcohol and ether, you can see that these two are also the examples of functional group isomers. One has the ether and other has the alcohol. And thiol and thioethers. The thiol and thioethers are similar to the alcohol, but you can just instead of oxygen we use the sulfur, but both having the same molecular formula. This is the example of thiol and this is the example of thioethers. If the thiol and thioethers having the same molecular formula, but their functional groups are different. This is the group called the thiol and this group is called thioether. So it belongs to functional isomers. Aldehyde versus ketones. If aldehyde and ketones groups are present, then these are also considered as a functional group isomers. This aldehyde CHO group is present, and here ketone group CO group is present. So these are belongs to functional isomers. Cyanide and isocyanate. Cyanide and isocyanate, in case of the cyanide, the carbon is directly attached to the carbon parent chain, and here in case of the isocyanate, the nitrogen is directly attached to the parent carbon chain, and both have the same molecular formula, so it is considered as a functional isomers. Alcohol versus phenols. In case of alcohol and phenols, this is an example of alcohol and this is an example of phenol, and both having the same molecular formula, so it is considered as a functional isomers. And here the only difference in case of alcohol and phenol, that OH group is directly attached to the sp2 carbon, whereas in case of alcohol the OH group is directly attached with this carbon. This carbon is sp3 carbon. And in the other examples, in case of pyracresol and metacresol, these two are also the isomers, but these two are not the functional isomers, because both having the same functional group. Same function, you can see the same functional group. Same functional group here also and here also actually. So all these three are the not the functional isomers. The essential condition for the functional isomers is that the functional group must be different from each other. So you can see that this must be have some position isomers or maybe chain isomers. Let us say whether it is a position isomer or chain isomer. Let us check the PG number here also 1, 2, 3, 4, 5, 6. There is 6, 1. This PG number is 6, 1. Here also the PG number is 6, 1. Here also the PG number is 6, 1. So the PG number is same. So it is considered as a position isomer. So these three are the example of position isomers. But if we compare this alcohol with this all the three phenol, these are the considered as a or this is the example of functional isomers. Last one is amine. We can divide the amine into three parts. One is 3-degree amine, and next one is secondary amine, and 1-degree amine. If the amine having the same molecular formula, if there is all the different degree amines having the same molecular formula, this all three are considered as a functional group isomers. The summary of this chapter, we have already discussed the chain isomers, position isomers as well as functional isomers. The only thing is that in the chain isomers there are different arrangement of carbon chain only. Either in position isomer different positions, and in the functional isomers different functional group. And we must remember the PG number also. If the PG number is same, that's called the position. If it is different, then it is called the same isomers.